Many students and many researchers and many people ask me about the different parts I have used in my foldable wing design. So today I will show what is the inside mechanism of a foldable wing ornithopter. So if you see this closed view, basically it contains three larger gears, right? I will show you this gears, right? And none of the part you will get like a ready-made part you will get in the market. So this is basically used in RC helicopter, big helicopter. So individually I have collected from different toys, different models. So this is a RC helicopter main gears. So inside this we have three radial bearings are attached. Okay, so if you see this hollow, there is a carbon fiber, and here radial bearings are attached. So coming to the first, I will explain about the frame. The total frame is made of carbon fiber, so which indicate it is highly costly project, because all parts are made of carbon fiber and it cut in CNC. So the best way in order to develop such kind of gearbox, you must design in either a CATIA, any modeling software, then simulate this so that exactly you can find, because it contains so many number of carbon fiber parts. The list of the part I will attach. So see, first things is the here is your crankshaft. It is a 4-bar mechanism. Basically, it is a 4-bar mechanism, and it is modified sun and planet gear mechanism. So here, if you see, when the there is a motor here. Yeah, here you can see clearly there is a motor. This motor is driven by, actually the power is coming from the battery, LiPo battery, and through ESC, electric speed controller, and receiver. Then there is a motor, small motor. This motor basically used for 300 to 400 gram of RC plate, but I used, if you can efficiently use, it can be up to 600 gram or 550 gram. This is a 550 gram model. So when it rotates, so it has two pinion. This is the pinion. You can see when the motor rotates, the pinion will rotate, and it rotates this intermediate gear. There is a another intermediate gears is there, and that this power is transmitted from first pinion, then intermediate gear, then this is the under pinion, and under this the two wheels will be connected here. So this is the crankshaft, and it is a simple 4-bar mechanism. And this coming to the wings have a 2-part actually. This is like you have a hand wing, and you have arm wing and hand wing. So this part is your arm wing where lift is produced, and I have under the hand wing parts here. So it is connected like this. So when it is going up and down, there is this mechanism. All are made of carbon fiber, and in all case I have used 36 different types of 36 bearings, out of which 3 are radial bearings. You can see the bearings. These are very small bearings, very small bearings. I used 5 mm bearing, 4 mm bearings. You can see these are the bearings, 2 mm bearings. So all different kinds of bearing are attached. If you see the crank here, everywhere, wherever there is a connection or relative motion between the parts, I used bearings. In order to make it more efficient. So here coming to the wing once again, these we have 18 aerofoils. You can see one aerofoil I will show you. Yeah, I can show you one aerofoil. This part, if you can clearly see. So this is the aerofoils. Like this, I have used 18 aerofoils. If you see clearly, this is one aerofoil. It is not visible clearly. I will show you the detailed part. So these are 9 aerofoils. 5 will be attached in hand wing, and 4 will be attached in forewing. Sorry, your arm wing. So it is like this. Now here lift is produced and here thrust is produced. Another important things is that out of these 5 aerofoils, the thickness is also you have to, the designing part I will explain later on stage, because it contains a lot of in order to it is a you can scale device, right? So here 2 are fixed and 3 are movable. You can see it is supported by a you can see there is a 5 mm carbon fiber tube. The tube is going from one place to other end, one end to other end. So here the first 2 aerofoils are fixed aerofoils in a hand wing. I am telling about hand wing, not arm wing. And this 3 are free about, and it can be rotated about the wing, about this 5 mm carbon rod, right? So that it can during downward it can move up, or there is a figure 8 motion and or oval motion. I used oval motion. This is not exactly figure 8 because the figure 8 trajectory is different. So it is the wing tip is a oval motion. If you see when it is going up and down, these are moving, means it is rotating about this 5 mm carbon rod. So that if you observe during flapping, it moves like this, right? It moves like this. So that during downward it will take it will occupy maximum area. It will come in contact with the air maximum area, and during upward it will in less area, right? So coming to once again coming to the gearbox, this is made of 1.2 mm this is made of 1.5 mm carbon fiber sheet, and then after designing in CATIA, I transferred into a CNC machine that design where G code and code is automatically generated, and I got this 2 casing part, 1 and 2, the front and back, and they are supported by carbon fiber tube. Everywhere, wherever the material, supporting material is carbon fiber, there is no other material, so that I can optimize the weight, right? So coming to these gears, now I purchased a long back from AliExpress. I don't know whether it is available or not, particular this intermediate gear having 27 number of teeth, right? So you can try with the different types of gears, whatever is available. You can use this kind of with a larger issue, those who want to make larger, but all parts you have to think how to design, how to because if a 2 mm 3 mm error also will disturb everything. So these parts, particularly the this is the crankshaft, connecting rod, and the gear dimensions are very, very important in order to properly transfer the energy from in order to optimize the energy, I mean to say, from motor power to the hand wing and arm wing. So you can look a close look to this gearbox once again. If I remember exactly, this is I think around 15 number of teeth, and this is 27 number of teeth. This is 144 number of teeth. You can find out accordingly the gear ratio. Basically, it is around 48 to 50. 48 if I remember exactly. So the teeth number slightly maybe up and down. So these connections are also very, very important. I told these are connected by bearings. If you see a close view, These are all everywhere. Small bearings are there. Wherever relative motion between the parts are there, I used bearings. So it is the overall weight is without battery. This is a lipo battery. I can this lipo battery, and the overall weight is about 450 gram. But with the battery, if I put receiver, it's coming around 500 to 520 something. It depends on what kind of lipo I use. On చేసారే హలో
ముందుకెళ్ళి ఇంకోటి
అన్బ్యాలెన్స్ వచ్చింది సరిపోటా ठीक है space is not available.
इतना ठीक जाते ना
हाँ छत छाड़ियोनि ଏବେ हम कई छ छाड़ अन्त धर धर क्लाइम करनी
উপরে উঠো
क्लाइम करनी
না করছি 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 পবনটা উড়ে দଉଛି
पवन होची सेटा पई से दिके
हां
काउ डोरी जाउची एडे ओटा ना
এই ছিল অ্যাটাক করিয়া ପାଇଁ এ ভাই
एक्सीलेंट हां तो सुनिए राइट कर हां
हां
एस
আজ ছোট ছোট দিল